Hey stats class, in this video I want to go over how to conduct a hypothesis test about a proportion using a spreadsheet. So remember, on the final exam, the only thing that you're going to have available to you is a blank spreadsheet. You are going to have access to this formula sheet, so you are going to use that, and I'm going to show you how to use that for these hypothesis tests. Alright, so notice in this wording of this problem, this random sample of 100 colored candies, 27% are blue. The candy company claims the percentage of candies is equal to 24%. So this is a hypothesis test about a proportion. It gives it away down here with the p's being everywhere, but on your test that you do later on for this, these last three chapters, it's not going to give you that. So you're going to need to know what to set up. And the setup here is proportions because it's talking about percentages. All right, now this 27% is from our sample. So that is the sample proportion. This is the value for P. So this is the one that we're going to set up. All right, it doesn't mention anything about a direction. It never says above, below. So the equal to 24 is the null. The not equal is the alternate. If it doesn't give you a direction, the alternate is not equal. All right, now we want to find the test statistic. So if you look at your sheet, your formula sheet, for proportions, and that's what we have here, this is how we get the test statistics. So it's P hat, P, P, Q, N. Those are the things needed. So I'm going to label them over here, P hat, P, Q, and N. All right, P hat is the percent from the sample. So it's the 27% of the 0.27. All right, P is what's the company claiming, but it's also just what we set up in the null and alternate. It's the 0.24 in this case. All right, Q is 1 minus P. All right, notice in the formula sheet here, that's PQ. It's not P hat, Q hat. That's not Q hat, it's Q. So it's 1 minus P, not 1 minus P hat. So this is equal to 1 minus, and I just click that 0.24 number. All right, and then N is 100 because it's 100 candies. All right, we want to find the test statistic, so we're going to plug in that formula. All right, I'm going to drag it over here so it stays on the screen as I'm typing this in. So equals, I'm just following from right to the right of the Z, the equals. All right, I need a parentheses around this because it's subtraction before division. The only way that happens is with a parentheses. So parentheses P hat minus P, close that parentheses, and then divide by, right? Underneath the division symbol is the square root symbol, so I can just do SQRT for square root. P again, so click the P value again, times Q, right, so times that, and then divide by N. Right, all that's under the square root symbol. So close off the square root symbol and hit enter. And there is your TS, test statistic. Alright, so all that goes into that formula. That's how you get that number out of there. So 0.7 is our test statistic. It says around the two places. I could just do 0.7, but 0.70 would be the two places. Alright, now the P value for this. This is a critical Z, and it is a not equal to. So we're going to do equals, this is the right tail. The 0.7 is in the right tail. It's above 0, so it's in the right tail. So I'm going to need to do 1 minus norm dist to get the right tail, which is what the p-value is. It's the percentage that goes into the tails beyond the test statistics. So just to give you a visual of what I'm doing here. There's the mean is 0. We found 0.7 as our test statistic. So that's above 0. So if we go on into the right tail, that's what we're going to find right here. That's the 1 minus norm dist. But again, because it's a two-tail test that we set up, I could have also been below negative 0.7. Alright, and so the way that I do that is I'm going to find one of these two. I'm going to find this one. I've already started the process. But then I'm going to double it. Whatever I get, I double it. And that will give me the area of that bottom tail, that second tail. So 1 minus norm dist. X is the test statistic, so I'm going to click that. And then this is the normal, standard normal, so mean is 0. Standard deviation is 1. So there's the area in the right tail. Oh yeah, sorry, cumulative. I always forget my cumulative. Comma 1. There's the area in the right tail. Now I need to double that. So down below it, I'm just going to write equals, click that, times 2. So there's my p-value. It wants to 3 decimal places. So I'm just going to click back until I get to 3 places. So 0.482. So the thing you got to remember here is the p-value for a two-tailed test is double the area beyond the test statistic. So whatever tail that the test statistic falls in, if I'm doing a two-tail test, whatever area or tail the test statistic fell. So if it had been down here, if it had been a negative number, hypothetically, then I need to find that area and then double it because it's a two-tail test. So we got to understand that that's what we have to do when we have a two-tail test. All right, then what's my conclusion? After you get these numbers, after the spreadsheet helps you get this number, you still need to know what to do with it. So the p-value is 0.48. That is above 0.10. So that p-value is not less than alpha. So we fail to reject. So it's either going to be B or C. B or D. Those are the two fail to rejects. When we fail to reject, it's because there is not evidence in support of the alternate. All right, so the spreadsheet can help with this, but you're still going to need to use that formula to help you get the things right in the spreadsheet.